Hello guys, welcome back to my stream. So today we're going to finish this question paper. So last time we stopped at question 7. So question 7, they said in the diagram below, the graph of x, the graph of f of x is given by tan of x, which is drawing for the interval. X is the element of negative 180 degrees to positive 180 degrees. So, okay, let's check the first question. The first question, they said write down the equation of asymptote of f in the interval such that x is the element of real number from what? From positive 0 to 180 degrees. So they are looking for the asymptote from where? From 0 to 180 degrees, meaning in a positive x-axis. So the equation of asymptote, we can find it by what? By this line. This line. And this line is the horizontal line, which is what? X. So the equation of asymptote is going to be x is equals to what? 90 degrees. You're going to get your 1 mark for that. So 7.1 x is equals to 90 degrees is our equation of asymptote. 7.2 they said write down the values of x in the interval. X is the element of what? Negative 180 degrees to 0 degrees, for which f of x is less than or equals to 0. So they are looking for a value of x where f is decreasing. So it has to be negative. It has to be this side because the only value that is less than or equals to 0 is this side. So we are looking for the values. So if we check from negative 90 degrees to 0, our graph is decreasing, is decreasing, is decreasing. So you're going to write your values of x as what? As 90 degrees is less than x, including what? 0 degrees. So those are the values of x where f of x is decreasing, or where f of x is less than or equals to 0. So, okay. 7.3, they said given g of x is equals to cos 2x plus 1, write down the period of what? Of g. So 7.2.1, they said write the period of g. So a period of g, you're going to say 360 divided by this number 2. So you are going to get your period. So you are going to say 360 divided by 2. Then you get your period to be 180 degrees. So you are going to get your 1 mark for that. 7.2.2. Okay, they said on the grid given in the answer book, draw the graph of g of x for the interval negative 180 to positive 180. Clearly show the intercepts with the axis as well as the coordinates of the turning point. So for this one, it's very simple. What you need to do, I'll use this graph to sketch. So what you need to do, since they said from negative 180 to positive 180, what you need to do is to say y is equals to cos of what? 2 open brackets, then close brackets plus 1. So you are going to start with the 0. Put 0 here, where x is equals to 0, and check what is the value of y. So if I punch my calculator, cos 2 into 0 plus 1, I found my y to be 2. So meaning our first coordinate is what? Is 0 and 2. So which is this one here. So then second one, you are going to do the same thing. You're going to say positive 90 degrees. If you put positive 90 degrees there, it's cos 90 degrees plus 1. You're going to get 0. So 0 is here. Our second coordinate is what? Is 90 degree and what? And 0. Then the third one, you're going to put 180 here. Remove 90 and put 180. So if we remove 90 and put 180 degree, what are we going to get? we're going to get 2, positive 2. So this point is way somewhere here because 2 is here. So is what is 180 degree and what and 2. Same thing with the other side because they said from negative 180 to positive. So here you're going to put negative 90 degrees. So if we put negative 90 degrees, what are we going to get? We're going to get 2. No, we're going to get 0. So 0 is here. So let's check with negative 180 degree. If you put negative 180 degree here, what are you going to get? 180 degree. You're going to get positive 2. So positive 2 is where somewhere here. So sketching the graph is going to be like this. It's going to be this way. So this is the graph of g of x. While this one is what is f of x. So okay, 7.3.2, they said on the grid, no, it's not this one. We already solved this one. 7.4, they said they use the graphs to determine the general solution of what? Of 2 cos third x minus sine x is equals to 0. So okay, first of all, we need to try to simplify that equation. So we're given 2 cos third x minus sine x is equals to what? 0. So we need to take sine to the other side. So it's going to be 2 cos third x is equals to sine x. So then we need to divide here by what? Cos x. So now we're going to have 2 cos squared x is equals to, we know that the sine x divided by cos x is what? Is tan x. So okay, we are going somewhere. So here we know this one is what? Is f of x. So I also want to change this one to do what? To be at least the g of x. How can I change this one? I need to add the negative 1 this side and also negative 1 this side. You will see why I want to add negative 1 both sides. So adding negative 1 is going to be 2 cos squared x minus 1 is equals to tan x minus 1. So we know this one is what? Is the same thing as cos squared x. No, sorry, it's not cos squared x. It's cos 2x is equals to tan x minus 1. So okay, I'm trying to have this one. So how can I add in order to have this one? I need to add the positive 1 here and also positive 1 here. So if I add positive 1, it's going to be cos 2x plus 1 is equals to tan of what? X. So now I have what? I have g of x is equals to what? F of x. So now we need to use the graph to find our what? General solution. So we need to find the value of x where g of x is equals to f of x. And if you check, it's where? It's here. It's where 2 graphs intersect. It's here and here. So okay, here we need to check something. So we are looking for this value of x here. So, okay, the way I'm going to search for this value, I'm going to start by writing 45 degree here. And also, yes, I'm going to write 45 degrees here. Here, let me write a negative 135 degree. So I'm going to firstly use g of x where x is equals to 45 degree. I want to search if both graphs are going to give me the same value. So is what cos 245 degree plus 1. What is the answer? Cos 245 degree plus 1. So it's going to give me 1. So let me check for f of x where x is equals to 45. So tan 45 is equals to what? Let me check again. 45 tan 45 is equals to 1. So meaning this coordinate here is what? X is equals to 45 degrees. So let me check this one also. So it's what? Is tan negative 135. So it's 1. So tan negative 135 is equals to 1. So let me check cos 2 negative 135 plus 1. What is the answer for that one? 2 negative 135 plus 1. Yeah, it's also 1. So this value here is what? Is negative 135, and this value here is positive 45. So my general solution is going to be, okay, let me write it here. So my general solution is going to be x is equals to 45 degrees plus 180k, oh sorry, yeah, plus 180k where k is the element of what? Of integer. So the reason why I say 180 degrees is because our period, we find our period to be what? 180. Remember to this question. What is that question? Yes, this one. We find our period to be what? 180 degrees. So yeah, that is the answer for the general solution using the graphs. So let's go to the next question. Oh, we are done with this one. So we are going to question 8. So question 8, they said in the diagram, C is the foot of the vertical building and D is the top of the same building. The height of the building CD is 6 meters. Okay, we see. Two observers are standing 19 meter apart at point A and B, where A and B and C lies in the same horizontal plane. A painter is working at point E on the building. The angle of elevation of D from A is 46.85 degrees, where D, E, B, this angle is 122 degrees, and B, what is B? BC A is 105.61 degrees. So, first question, they said they calculated the length of AC, the distance between the observer at A and the foot of the building. So, AC, no, there's an AD. Yeah, AC. We need to calculate this distance, A to C, this distance. So let's check something. From this triangle, what do we know from this triangle? We know that this triangle is what? Is a right angle triangle. It has one there's one side that we know which is 16, DC is 60. And we also have angle A, which is 46.85 degrees. So we have what? We have right angle, sorry, let me write it a good way. I have a triangle. No, the triangle, this one is not going to work. Let me just draw. So we have a right angle triangle here. So you sketch it outside. So we have DC, which is 16. We also have this angle, which is what? 46.85 degree. We are looking for what? We are looking for this side. So how can we find this one? This one is the adjacent of what? Angle A. So we can simply say opposite of adjacent is what? Is tan. A is equals to what? Is equals to opposite, which is 16 over adjacent, which is AC. So let me write it here. So 8.1, we have tan A is equals to 16 over our adjacent is AC. So when our angle A is given as 46, yeah, 46.85 degree. So it's the same thing as tan 46.85 degree is equals to 16 over AC. So cross multiplication is going to be AC tan of 46.85 degree is equals to 16. So we need to divide by tan that angle. So it's going to be okay, so AC is equals to what? 16 over tan 46.85 degree. So it's 16 over tan 46.85 degree. So it's going to be 14.999. So we can simply round this one to what? AC is equals to 15 meter. So now we have this length, which is 15 meter. So okay, let's go to the next question. The next question, 7 marks. They said calculate how far the painter at E is from the top of the building. So the painter is where? Here at E. So they want us to calculate how far from the top of the building. They want us to calculate this length. They want us to calculate the length. This length. So we have, okay, let's sketch this thing. We have DC, which is what? 16. And now we have a painter at point E, and they want us to calculate this distance. They want us to calculate this distance. So how can we calculate that one? So we need to interpret our diagram. So since we have this side, we have this length and this length, we can calculate this length, right? Yes, we can calculate this length. And then after calculating this length, we can, okay, since this triangle EBE is also a right angle triangle. So if we calculate this length and then calculate either this angle or this angle here, then after that we can also use what? The properties of right angle triangle in order to calculate this one. If we calculate EC, yes, we can minus EC in order to get what? In order to get ED. I hope you're following and you understand. So, okay, first of all, I'm saying let's calculate what? This length, BC. So, let me erase this so that I can explain while you see the diagram. So, I'm saying let's calculate BC. In order to calculate BC, what do we have? We have this length and this length, an angle. So we can use a cosine rule. Cosine rule which says AB squared is equals to AC squared, then plus what? BC squared minus 2 AC BC cos of what? Cos of angle C, or let me just say angle BCA. So I hope you're following. So okay, now we know triangle what? No, we know AB. AB we already calculated to be what? 15. Okay, no, let me open a new page in order to write this on. So it's 8.2. I said we have AC squared is equals to no, it's AB, sorry. It's AB is equals to AC squared plus BC. BC squared minus 2AC BC cos of what? Cos of BCA. So this one I already calculated. This one is 15. AC. No, AB is 19. Sorry about that. AB is 19. Then AC, yeah, is 15 degree. BC we don't know. Minus 2. Then AC is what? 15. BC we don't know. Then cos of what? (105.61). 105.61 degree. So using my calculator is going to be 19 squared is 361 is equals to 225 plus BC squared minus this one state, and now let me also multiply the cos. So it's 30 times cos of what? 105.61. So it's going to give me positive 8.073 BC. So now is what is BC squared plus 8.073 BC. Then I'm going to take this one inside. It's going to be 225 minus 361. So it's negative 136 is equals to 0. So okay, now you see we have a quadratic. So we need to use the quadratic formula in order to solve this one. So it's going to be what? It's going to be okay. And let me say let BC equals to x. So now we have the equation x squared plus 8.073x minus 136. So now I'm going to say x is equals to negative b plus or minus square root of what? B squared minus 4ac all over 2a. So this one is going to be x is equals to negative 8.073 plus or minus 8.073 squared minus 1 negative 136 all over 2. Then our a is 1. So let's punch this one. So I'm going to find my x is equals to or x is equals to. So let me go back there. So it's negative 8.073 plus 8.073 squared minus 4a 1 negative 136 2 1. So the first value that I'm getting is 8.30. Then the other value is negative 16.38. So since we know we don't have negative distance, so this one is not applicable. So therefore our distance BC, our distance BC is equals to 8.30 meter. So okay, this question is 7 marks. So we have what? We have BC, which is 8.30. So this one is 8.30. So now we do have what? We have a right angle triangle. We have a right angle triangle where here is what is 8.30. So here we have what? 90 degrees. So let's check something. We can find this angle here, which is angle BC, BE. We can find angle BEC by saying 180 minus 122 degree. The reason angle on a straight line, grade 7 or grade what? Yeah. So we can find this angle. So 180 minus 122. We find this angle to be what? 58 degrees. Angle on a straight line. So you need to include this one here. So we can find the angle BEC by saying 180 degree minus 122 degree. Reason angles on a what? On a straight line. So now this angle is what? Is 58 degrees. So now we have a full triangle that has all the information that we need. Here is what is 58 degrees and this side. So we are looking for what? For EC, this angle EC. So this angle EC is the adjacent of what? Of this angle. So this is the opposite of what? Of this angle. So you're going to say tan 58 degree is equals to opposite, which is what? 8.30. Then our adjacent is what? Is EC. So let me go there. So I said this tan 58 degree is equals to 8.30 divided by EC. So same thing, cross multiplication is equals to 8.30 divided by what? Tan 58 degrees. So if you punch this one in your calculator, you're going to get 8.30 divided by tan 58 degrees. So we find our answer as 5.19. So we can now conclude that our DE is equals to what? Is equals to DC minus EC. So it's 16 minus what? 16 minus this length, which is 5.19. So 16 minus 5.19 is going to be 10.81. So let me explain again here. So I said we have this length, which is 5.1, is it 18? Yeah, no, it's 19. So 5.19, we have this length, and we are looking for what? ED, and we have what? We have this length DC. So in order to find this one, we just simply say 16 minus what? 5.19. Then that's where we'll get our 10.81 meter. So you're going to get full marks for that, 7 marks. So we are done with this question. 7 marks. So now we are going to question 9. So question 9 is circles. So okay, they said in the diagram, ABCD is a cyclic quadrilateral, and the BC is produced to E. AC is drawn when A1 triangle, angle A1 is supposed to half B. So A1 is supposed to half B, and A2 is equals to 46 degree, yes, we can see, and the C1 is equals to 81 degrees, as we can see. So first question, they said calculate with the reason the value of A1. It's A1. So okay, here we need to know the properties of cyclic quadrilateral. So cyclic quadrilateral, and especially in this form, we have this angle that we know, which is what? 86 degree. When this one is what? A, D, B, C. So this angle here is equals to A, the whole A. The reason is what? It's the exterior angle of a cyclic quadrilateral. So even here, this whole angle here is what? Is 86 degrees. So the first thing that you need to do is to say AU1 plus what? A2 is equals to what? Is equals to 86 degrees. The reason I'm saying it's a cyclic angle in a cyclic quad, exterior angle of a cyclic quad. Yeah, then after that, you're going to say what? You're going to say A1 plus what? This one, we know A2 is what? Is 46 degrees. Is equals to what? 86 degrees. So now you need to take 46 to the other side in order to get A1. So we get our A1 as what? As 40 degrees. Done. Reason I'm saying is a exterior angle of a what? Of a cyclic quad or quadrilateral. Yes. So we are done with this one. We have our 2 marks. So now let's go here. They said hence prove that AD, this length AD, is equals to DC. So they want us to prove that this length, they are equal to each other. So how can we prove that? So we know that this one is what? Is 40 degrees. So we need to prove if this angle is also 40 degrees. The reason for that, I'm saying, since this angle is opposite to this line, and this one is opposite to this line. So we need to prove that even their angles, they are equal. So in order to prove that, if we find that C2 is also 40 degrees, we can conclude that AD is equals to DC. So to do this, we are going to say, okay, using this property. So A1 is equals to what? 1 over 2B. We are given this one. So what is the value of A1? We find the value of A1 to be 40 degrees. So 1 over 2B. Then reason is given. We are going to use this reason given. So now we can conclude that B is equals to what? It's equals to 80 degrees. So it's like cross multiplication. It's equals to 80 degrees. So we have this one which is 80 degrees. I'm just trying to find the pattern in order to find the value of this one. So another thing that we need to know is that angle D plus angle B is equals to what? 180 degrees. Reason is the opposite angles of what? Of a cyclic quad. So now we can do what? We can say D is equals to what? 180 minus 80 degrees. Why? Because B is what? Is 80 degrees. So angle D is what? Is 100 degrees. So we have this angle which is what? 100 degrees. So okay. Allow me to erase this one, since now you understand how we got the first one. So okay, so now since we have this one and this one, we can find C2. Angle C2 plus angle D plus angle A1 is equals to 180 degrees. Reason, sum of the angles in the triangles, they add up to 180 degrees. So C2 is equals to what? 180 degrees minus D, which is what? 100 degrees, minus A1, which is what? 40 degrees. So 180 minus 100 minus 40 is equals to what? Is equals to 40 degrees. So now you can conclude that, okay, therefore, since C2 is equals to A1, A1, which is equals to 40 degrees, it means what? It means even AD is equals to DC. Reason for this, side opposite equal angles. Yes. So side opposite equal angles. So yes, we find that AD is equal to DC. So both sides are equal because what? We have two angles that are also equal. So I think we are done with this one. Yes, we are done. Let's go to question 10. Okay, question 10 is a proof. So guys, I'm not gonna show you the proof. I guess you know the proof by now. So proof, you just need to go to your textbook or where they give you the proofs and cram the proofs. Cram and understand the proof and go and apply the proofs. Just need to know the properties of proportionality. The proof is very simple, so I'm not gonna do this one. Let's go to question 11. No, it's still question 10. But this 10 point. Okay, 10.2. So okay, 10.2.1. Here they said in the diagram, O is the center of the circle. And triangle PWS is drawn with P, W, and S on the circle. And OR is perpendicular to PS. PRS is produced to E, okay? And SW and OT intersect at the V. Okay, you can see. So first question, they said the proof with the reason that OR is equals to, no, OR and WS is equals to 1 of 1. So this is the ratios. So okay, in order to prove this, we need to check something. This angle is also 90 degrees. Reason angle in a semicircle or angle subtended by the diameter. So we can conclude that this angle is parallel to this angle. Why? Because corresponding angles. So if this line and this line, they are parallel to each other, we can conclude to say this thing is a proportionality. So now they want us to prove that OR and the what WS, they are 1 to 2 ratio. So which is correct. So what I was explaining, we need to say PS and W. PSW is equals to what? Is equals to 90 degrees. Reason, I said angle in a semicircle. So what else? PRO is equals to what? 90 degrees. Reason given. So now we can conclude that PSW is equals to PRO. So meaning is parallel to what? SW. So we can use what? We can use proportionality to say PO divided by OW. Okay, I'm saying PO divided by OW is equals to what? Is equals to PR divided by what? RS. Do you agree with me? The reason is what? Proportionality theorem. Why? Because OR is parallel to what? WS. This thing. So then after that, I'm going to do what? I'm going to do cross multiplication. Okay, but before I do cross multiplication, there is something you need to know here. We know that this one is equals to this one. The reason is because radius radi. So we know that PO is equals to what? OW. Reason is radi. So now, since we know this one, they are equal to each other. Okay, equal to each other. So even this one, they are also what? Equal to each other. So now we can conclude that what? P, R, they are also what? Equal to each other. These two, they are also equal to each other. Because you can see this angle and this angle, they are equal. Reason is a corresponding angle because those two lines are parallel to each other. So now we can conclude that yes, indeed, OR is what? And WS, they are 1 to what? To 2. Yes, now you have all the reason to conclude that they are 1 to 2. So okay, now they said what? Calculate the length of PT if ST is given as 15 units. Okay, this one is going to be simple because we already did the complicated part. So okay, we are simply going to say OV divided by what? VT is equals to what? RS divided by what? Divided by ST. Okay. So I said what? OV divided by what? VT is equals to what? RS divided by what? ST. Reason is because we know that OR and WS are parallel. So even this triangle here is also a proportionality. So you will say proportionality theorem because we have two lines that are parallel to each other. And by given that this one is 15, yes. And also, remember here we are also given that OV is 1 and then OT is what? Is 4. So meaning here is 1. This one is a ratio, guys. So if this one is 4, okay, let me use a different color. So if this one is 4, so we know that the VT is 3 because it's 1 minus 4, which is 3. So this one is what? Is 3. VT is 3. So I'm going to conclude and say is what? Is 1 over 3. The reason I'm saying is a proportionality. Even this side is 1, even this side is 3. So now we're going to do what? We're going to say RS over st, which we don't know, is equals to what? Is equals to 1 over 3. Is the ratio that we're given. But what do we know? We know we have a what? We have the value of st. Yeah, st we're given as what? As 15. So we're going to say rs over what? 15 is equals to what? 1 over 3. So rs is equals to 15, sorry, is equals to 15 times 1 over 3. So rs is what? Is 5 units. So I hope you're following. It's 5 units. So we have rs, which is what? 5 units. And we said what? We said rs is equals to what? Is equals to PR. You remember? We proved in 10.2.1. We proved that in 10.3.1. So now we can conclude that PT is equals to what? 5 plus 5 plus 15. So is this 5 plus this 5 plus this 15? So which is what? Which is 25 units. So now you have your 15 marks. So okay, now I think we are going to the last question. Yeah, last question, 20 marks. So okay, question 11. Question 11, they said in the diagram, A, B, G, and F lie on the larger circle. A smaller circle is drawing to touch the larger circle internally at A. EA is a common tangent to both circles, and EDCF is a tangent to the circle at C. AC is produced to G. AF cut the smaller circle at D, and AD, CD, and GF are drawn. So okay, let me interpret this thing. What I see, okay, I see this one is tangent to both circle, the big circle and the small circle. What else? I also see angle subtended by angle in the same segment, which is this one. I also see this angle is equals to yeah, the person who said that this paper, they are good, man. So okay guys, let me try to analyze this one. Okay, wait, so this one up until here, yes, because this line and this triangle, so now I can say what? I can say this angle is equals to this one. Angle in here seems angle tan chord theorem. Yes, it's tan chord theorem. Okay, let me tan chord theorem. Stan chord theorem. Okay, there is also this triangle, this small triangle in the yes. So guys, I'm trying to analyze this. So I have 1, 2. So here they said if EAG is equal to x, determine with reason 4 at the angles that are equal to x. So I have what? 1, 2. Okay, I still have 2 now. Okay, now I still have 2. Okay, let me try to write so I can locate this thing. So here I have D1 is equals to EAG, which is equals to x. Reason is a tan chord theorem. It's a tan chord theorem. So this angle here is equals to this one because you can see by this one, tan chord theorem. Alright? Yes, so the second one. Okay, it's this one. So this one again and this one is a tan chord theorem. So I also have let me say AFG is equals to EAG, which is equals to x. Tan chord theorem, same reason. Okay. Okay, hey, the person who said this paper. So there is this. Okay, you see the small here. This line is also a tan. It's a tangent line. This one. We have this triangle here. Yeah, the person who said the paper is cool with me. So this angle C1 is what's what? This one. It's a tan chord theorem is that one. So C1 is equals to D1, which is equals to X. Reason tan chord theorem. Okay. So, okay, let's check something. So we have C1 is equals to C4. Reason, you can see that this one and this one is just a vertical opposite. So C1 is equals to what? C4, which is equals to X. Reason, vertical opposite angles, they're equal. So we have 1, 2, 3, 4. Yeah, I'm done. So the first one is what is this one? Tan chord turn chord, turn chord. So you just need to be very careful here. Try to check. We also have a turn chord here because this small circle has two turn chords. Is this one and this one. So okay, let's go to 1.1.2. Here there's a proof that AG times AC, no, AG times AD is equals to AC times AF. Okay. Let me open the page. Okay guys, let me charge my laptop. Give me a few minutes. Okay, so it's 11.2. But no, let me just solve here because in order to solve this thing, I must be watching the diagram. So I hope you understand the first one. So 1.1.2, they said prove, okay. First thing, we need to prove that AG, okay, is this one AG and what? AD is equals to AC times AF, okay. Okay, guys, let's check something. You remember this angle, it was X, and this angle here, it was X. So we can conclude that this one and this one, they make a line DC to be parallel. They make line DC to be parallel. That's the first thing. So if they make line DC to be parallel, it means this whole triangle is also what? We are also going to use the proportionality. So that's the first thing we need to locate. So D1 is equals to what? Is equals to AFG, which is equals to X. The reason for this is what? It's a corresponding, or we prove this thing to 1.1.1, or you can just write the corresponding angles, they are equal. So since they are equal, we can now conclude that DC is parallel to what? To GF. Right? Yes, DC is parallel to GF. DC is parallel to FG. So if you start by DC, you also need to start by FG. So okay. Now after that, we can simply use what? We can simply use the proportionality and say AG divided by what? Divided by AC is equals to what? Is equals to AF divided by what? Divided by AD. Okay. Yes. So it's AG divided by AC, then AF divided by AD here. So cross multiplication is going to be AG times AD is equals to AF times AC. So here the reason you can also write that it's a proportionality theorem. Why? Because DC is parallel to what FG. You can write that the reason here. So this thing is the same as what? As this thing. So they will give you your full marks for that. So, okay, now we need to go to this one. They said prove that, let me erase this. Triangle AGF, okay, this big triangle is what? Is similar to triangle ABC, okay. So we are working with this triangle here. All right, and this big triangle. So we want to prove that they are similar. So, okay, to prove, allow me to erase this. So to prove that they are similar, first thing is that we have angle in the same segment, which is this one and this one. So, should I say G? Yes, I can say G. Okay, let me use blue. So angle G is equals to what? B2. Reason, angle in the same segment. So we have this one, they're equal to this one. So now we can say angle AFG is equals to C1, which is equals to X. Remember, we proved this one in what? In 11.1. You remember when we said AFG, this angle is equals to what? C1. Yeah, it's equals to C1. Why? Because we know C1 is also equals to what? Is equals to D1. And D1 is equals to what? Is equals to F. So we don't need to include all those steps, but we can just say AFG is equals to what? C1, which equals to X. We proved that thing in question 11.1. So I was just reminding you. So another thing, now the last angle, you can just simply use sum of the angles in a triangle. So we can say see what? No, it's not C, man. It's A2. Angle A2 is equals to what? Angle A3. This angle, they're equal to each other. Reason, sum of the angles in a triangle. Sum of the angle in a triangle. So now we can conclude and say triangle what? Triangle AGF is similar to triangle ABC. Reason, angles. Yeah, I'm going to get your formats for that. This one. The person who said this paper. Now they said the proof that GF squared is equals to BC times what? FC times AF divided by what? AD. Yeah. So okay, let's try. Since we have all the information, we can't be defeated by the last question. So that's what 1.11.4. So first we can say since we proved that the triangle AGF is similar to triangle ABC, we are allowed to say GF divided by what? Divided by BC. I'm saying GF, this GF divided by BC is equals to this one, AF divided by what? AC. Reason for this is because those two angles, they are similar to each other. So now we can do what? We can do cross multiplication because we are looking for G. You see here, we're looking for GF squared. So we can say GF is equals to what? BCAF divided by what? AC. So we are going there. So we have BC and what? AF. So the remaining one is what? Is this one, AC. So, but AC, this one, it has to lead us somewhere. We have to make it equal to something. This is a question mark. We need to find out how can we represent this one. So, now let's go to, since we proved a lot of similarities, let's go to, okay, let's go to triangle ACD, which is similar to what? Triangle FGC. So ACD, this one, this small one, ACD, and what? And FGC. Okay, this small one. So I'm saying this triangle ACD is similar to what? To triangle FGC. So here we're going to say what? AC divided by GF guys, for this question, the last question, I don't want to lie. My brain is tired. So if I get time, guys, let me go back and try to understand this question, because I'm stuck from here. I don't know where to go. So let me try to end the stream here, and I'll come back for another stream, especially for this last question, because I don't want to give you something that you don't understand. So I want to give you the best explanation. I also don't understand how I can use this one. So I used 11.3 because we already proved that this one is similar to each other. So but this one I don't understand. So thanks guys for watching. If you find this helpful, please subscribe, like and share. Until we meet again. If you also have questions, please comment before I end the stream.